And this is Alister Scott talking about a very sensitive subject.
Thank you. Hello there. I'm going to be using the F word a lot in this talk, like a lot. I apologise in advance if I offend. You all know the F word, don't you? It's also known as the F-bomb. We test engineers use it all the time. Yes, that's one. Flaky. So last year, I went to GTAC in Kirkland, and like a lot of other people there, I was very shocked by the language. Every second talk was dropping the highly offensive F word. Over lunch, we were jokingly calling it Flaky TestCon 14. There were lots of talks about how to reduce it, ways to minimize it, and what to do when you have a flaky test. Flaky tests are something that most of us experience almost every day in our lives. They cause us no end of despair. And we should be afraid, very afraid. The concept of flaky tests has the potential to bring our testing profession down. There's been lots of solutions proposed around test design and test resilience, but we continue to suffer from this problem. The solutions don't work. As the F word gets dropped more and more, people start to doubt whether any tests are reliable and if testing's worth it at all. What if testers are flaky like their tests? We need to kill the term flaky. So I got back to work after the conference and I was sitting at my desk and I overheard a developer dismiss a failed build as, "Oh, that's just some flaky tests." I was shocked. I was shocked and offended. The F word, an excuse to ignore testing. People were talking about our work and they were using the F word. So I swore to myself from that moment forward that I would not dismiss any issues as flakiness. I would stop calling our tests flaky, but if our tests aren't at fault, what is? Our applications. You see, flakiness implies that it's a test problem and that no one needs to worry about it from an application development point of view. But what if it's not the test problem? What if it's our app's problem? Developers had started to use the term flaky to describe any failing test. Imagine how useful a flaky smoke alarm would be. It would go off very often, and you'd be like, well, that smoke alarm, it's just flaky. Let's just ignore it. You may as well not have a smoke alarm. You may as well ignore all testing. Why have testers? Why have test engineers? And like that, our profession became under threat. So how do we get to the bottom of flaky? Well, imagine you had a toaster that was sitting directly underneath your smoke detector and it was on a very high setting. Is your smoke alarm still flaky? Or is the thing that you're measuring not quite right? We need to get to the bottom of it. We need to look at the whole story and stop using the F word. Let's look at our applications. So not too long after this happened, we had another issue with inconsistent or flaky tests at my work. So we had a whole bunch of acceptance tests and they gave us really good confidence that our app was ready to release to production. And we did that very frequently. And we'd never release our app unless all our acceptance tests had passed. We had about 500 tests and we ran them in parallel in about 50 groups, each having about 10 tests. And it meant that the entire suite could run in as little as 10 minutes for the entire suite, which was pretty sweet. And so we wanted to get a build released, and 5 of our 50 groups failed on the first run. So what we did was we reran those 5 groups, and I think then one group just failed. So we reran that one group, and it passed. Our build was green, and we released it to production. We didn't ask why our tests had failed in the first place. So shortly after we released to production, we started seeing our customers were losing their sessions and crashing. But all our tests had passed. We had a closer look and found that we had an obscure caching bug where the display mode between desktop and mobile was being incorrectly cached and displayed for the wrong user's session. This was killing the user's session, and it was affecting our sales. It wasn't immediately obvious, as it wasn't happening for every customer. It was only happening for about 10%. 5 groups out of 50 is also 10%. Our tests had found this bug, but we'd completely ignored them. We'd ignored them until it didn't happen anymore, but our tests knew that we had an issue. Trust the tests. Don't rerun blindly until you get the response that you want. Find the issue and fix it. Kill any possibility for flakiness. We had another situation with an app that I was working on, and we were running some tests in parallel, because running tests in parallel is very efficient and replicates how our users use our systems. We encountered some flakiness or inconsistency in our test results. Our app happened to have a feature that we didn't know about, where a subsequent logon to the first would destroy the original session in some cases. So if 2 of our tests happen to run in parallel at exactly the same time, the second test would make the first one fail. Spending time trying to make our tests resilient or reliable would be fruitless. It was built into our application design. Our app should have been testable, and it shouldn't have killed the subsequent sessions. It wasn't meant to happen. So rather than going on a flakiness hunt for our flaky test, we refused to believe in it, and we discovered application quirks that were disguised as test flakiness. Our faith in testing was restored. Our tests had revealed the true story. Thank goodness it wasn't a flaky monster under our bed. We'd shone our torch, our trusty test on it, and realized it was just some dusty bits of our application design. There was nothing to be afraid of. We had a single page internal web app that I was working on, and it used dialogues upon dialogues with pop-ups and asynchronous server calls everywhere. Our tests would dismiss a dialogue, and it would miraculously reopen when a callback was later received. It would make our tests very flaky. What we could have done was make our tests resilient as to expect a random pop-up at any moment and dismiss it. And I have seen that done. But why should we write such complicated tests? What's the real issue? Why should we have highly resilient tests for such a clunky application? Shouldn't we look at the reason behind the flake? We decided to work as a team to make our app more testable, to show spinners for AJAX calls, to make dialogues not miraculously reappear, and to provide hooks so you could know when asynchronous stuff was happening via JavaScript. We did this, and guess what? Our tests were suddenly consistently passing. Flakiness 0, application testability 1. I worked on another app, and it was to order pizza. It was a multi-step flow, and every step relied on some state from a previous step. If we were to write tests that included every step and any combination of steps, there'd be lots of possibilities for flakiness and inconsistencies. Instead, we chose to write a test-specific controller, which was embedded as part of our application, to instantly display any page in our app with any state that you required. So there was no navigating of pages and no constraints around time or data. If you can set up a single URL with everything that you need to test some functionality, this means your tests can be focused on testing and avoiding flakiness by avoiding navigation and layers of setup and options. We built testability well and truly into our app. The integration of testing into system development saved us from flakiness and complicated after-the-fact test writing. Don't be afraid to add testability-specific features to your apps that don't serve a functional purpose. I recently had to get new tyres on my car, and I realized that a lot of tyres have testability features. They're called tread indicators. They don't serve any functional purpose. A tyre doesn't need a tread indicator to operate, but it does make it possible to quickly and easily test the tread of a tyre without any complicated measurement instruments. Why don't you consider investing in similar testability features for your apps? These are two of the most annoying messages and pop-ups I see on internet sites that I use. They're particular to sites that don't cater well for browser navigation. So tests for these sites can be flaky, as it's really hard to handle these pop-ups in test automation. They also cause a lot of fear in our users. Has it taken my money? Have I double booked? How long should I look at this screen before I refresh? So there's a lot of user panic. But what if we built our apps so that it didn't have these problems? Our tests wouldn't need to cater for them, and we'd have a better user experience. How? Well, we design and build your app with testability in mind. An integrated team of developers and testers throughout the whole process is ideal. A testable app is a usable app, and usable apps aren't flaky. So you might be asking, what can I do to help kill flaky? We all have a role to play in restoring faith in our profession and pushing flakiness into extinction. Number 1, don't blindly rerun tests. If you roll a dice enough number of times, it'll give you the number that you want. But is that the same thing that happens if a real user rolled a dice? No, it's not realistic. We need to look at why it failed the first time, why you didn't roll a 6 straight away. There's a reason you didn't roll a 6. It's a dice after all. Maybe you need to use a different approach altogether. Number 2, use flaky tests as insights into your apps. Flaky tests are not useless. They're telling you something. You just need to work out what that something is. Be the test whisperer and decode it. You'll be rewarded with a secret about your app or an area for enhancement. And number 3, build testability into your apps. Flakiness comes from after-the-fact testing. We're not an afterthought. Testers and test engineers should be part of application design teams. We need to consider and build testing and testability into our application designs. Efficiency, effectiveness, and testing confidence comes from this strong base. I'd like to finish with a final message to flaky tests. What I do have are a very particular set of skills. Skills I have acquired over a very long testing career. Skills that make me a nightmare for flaky tests like you. I will look for you, I will find you, and I will kill you. Cheers.
Thank you, Alister. You have a lot of questions coming your way, so it's a good thing we've got a lot of time.
Sure.
So the first one, isn't it a question of probabilities? A bug that manifests in a flaky result is less likely to be seen in production than a test that always fails. How do you convince the team members that fixing flakiness is a priority?
Let me just read it again. I guess I sort of disagree, because I have seen a lot of flaky, doing a lot of research into these flaky tests, which I've sort of demonstrated today. Like, I have actually shown that a lot of these things do actually come through in production. We just don't realize it. Like, so my example of where we had a quirk in our application where like multiple logins, the second one would kill the first. No one had any idea about that. It was happening in production. We just had no idea about it. Our test was flaky because of it, but it was an application issue all along, and so it was actually in production. The question's not there anymore, but yeah, that's my...
How do you convince the team members that fixing flakiness is a priority is the other part?
Sure. Well, I think a good way to do that is to actually like make the prominence, or make flakiness very prominent. And so ways I've done that before is like make sure that everyone can see that we've got a flaky build. So having like things like build lights and build monitors and things like that, making it really clear that we've got like like our build is failing and it's red, we can't push that. And then people will start seeing that and say, well, why is it red? Okay, let's have a look into it. And then sort of dismissing that, hey, it's this flaky test, and then like really starting to delve into it and looking at it. And people often say, well, it's going to cost a lot of time and money to do this, but like not doing it is also going to cost a lot of money and time and product issues and things like that. So, yeah.
Our team finds that tests fail due to hardware, OS, network, and job management problems, often enough that it is not worth investigating flakiness below a certain threshold. Do you agree with this strategy?
Yeah, well, no. So I think that like if you so any one of those things like can cause the flakiness in our tests. So if you're finding those, we need to actually make a testability feature that we can get rid of that flakiness. So if we've got an issue with like network, we need to say, hey, how can we make our app like better so it can run on like flaky networks? Or how can we make our app better so that it can run in a test mode where it doesn't need to use the network? Or it's like, how can we actually improve our app to like mitigate any of these like potential reasons for flakiness? So like if you can, like an example, an app I worked on, we had like all these issues around flakiness around time, and then so we're like, well, how about we just like make our app so that we've got a mode where it doesn't sort of like worry about time. We can test everything else, and then we can like test time separately. And instead of time affecting like every single test that we've got, we didn't worry about time, and then we could just test time in this little thing over here. So I guess it's just worth looking at like any of these issues that people say, hey, that's the reason for flakiness, and then just trying to work out, hey, can we use testability to solve those?
The challenge with flaky tests is that they are very difficult to reproduce. Do you have suggestion for pinning these down?
Yeah, that's a very good question. So what I've found to work out what it is, because as I said, I've spent a lot of time doing this. So things like logging and screenshots and recording videos of tests running, like these are really good things. Like a lot of like CI tools do this anyway, but they're really good techniques to actually like basically, you know, be that test whisperer trying to work out exactly why it's happening. Oftentimes, like you can run it like locally in a dev environment and it passes every time, and then every time you run it in CI, but when it's like running in parallel, it'll fail. So yeah, if you can put things like turn logging on, put in like debug statements, if you can capture screenshots every time it fails, or like you have a mode that every time it runs, it does a screenshot on everything it does. Like all these different things that you can do, you can use all that information to realize, hey, this is why it's flaky. And that's what we did for like the issue where we had the subsequent logons, where like we really need to actually start looking at the screenshots and the logs and trying to work out exactly why this is failing. Because every time we ran one of those tests locally, just as a single test, it would pass. There would be no way it would fail. But when we ran it in parallel, it would fail. So,
and I'm going to add one thing to that because I have the power of the microphone. I would also say production monitoring, so that
yes.
You actually realize like this is a real problem in production. This isn't just a flaky test. Yes, actually 10% of users could be correlated back to this thing in production.
Exactly, yeah, because like the example I gave where 10% of our users were like completely affecting our sales, like that was production monitoring, so it's like really important.
Okay, back to questions. What about diminishing returns of test stability? How do we justify X weeks of software engineers' time fixing something that only affects tests versus stabilizing the tests themselves?
Yeah, that's a good question as well. So, Yvette, I think you talked this morning about Google Maps and spending 2 weeks on the sort of like flaky test.
Unfortunately, I did.
Yeah, so, I mean, we already spend a lot, like, we spend a huge amount of money and investment on flaky tests, right? Like, we do that already. So, by reinvesting that effort in testability, I've seen that the benefits are much more substantial. So it's not about spending more money on testability. It's just about spending less money on flakiness, spending more money on testability, like diverting that money to testability. So I've seen it, like in all the examples that I presented. Like I've seen it in a team how greatly the team is so much more confident if they can have consistent green builds and being able to release to production consistently without any flaky tests. Like it's like a priceless thing to have. So,
is it or is it not a general best practice to ship internal testability hooks as part of the shipping software package? If we do, aren't we exposing internal tools to customers that increase the size of the shipped software but provide no use to the customer?
So all the testability stuff that I mentioned in my talk, we basically, through config, we disabled it in production builds. And I think we even, in staging builds, we actually disabled it as well because we wanted that to be very much like production. So if any sort of testability feature, like I talked about the pizza app, so any ability to basically like jump straight into like customizing a pizza and setting up all this different data, like there was no way that a user could access that in a production or staging environment. So we had a lot of config tests, so everything was heavily driven by config, and we came up with a cool idea to actually have like unit tests for config, so you could actually, every time you change config, you'd actually write a unit test for it. So we had a lot of confidence, I guess, that our production config didn't include any of our testing stuff, because I don't think it's very good, like from a size point of view, and also from a like risk management point of view. It's not very good to actually like ship testability features to customers.
How do you know that you are validating real-world conditions when you test a specific controller?
Yeah, so with the test controller, like it was full stack, so it did use services, it did use the database. It just was really like, I guess, like a setup, like a quick mechanism. So it was like a basically way of setting up state in your application and redirecting to a certain point so that you could actually see that. Saying that, it is a valid question because like they weren't the only tests that we had. So I think I mentioned we had about 500 tests, and about 450 of those approximately would have used the test controller. So they're like very targeted. They would just be the way the test would work. It would say, hey, I call this test controller, I get to where I want, and I do some assertions. The remaining 50 are the sort of like the top of our test pyramid, and they're our end-to-end real user tests. So they basically go through from the start of like specifying who you are to order pizza, selecting your address, going through, choosing a Hawaiian pizza, doing all sorts of stuff to it, and then saying, hey, it needs to be delivered to my door and being able to see a pizza tracker. We had like a handful of those. We limited them. There was nowhere near as many, but they didn't use any of the testability sort of features because they were representative. And the benefit of those, as I said before, our testability stuff was disabled in production, but because our end-to-end tests didn't use any of that, we could actually run those in production, which we did. So we actually ran them in dev, test, staging, and we actually ran them in production. So every time we did a production release, we'd run those. They would order 3 weeks in advance so we could have time to cancel them. But yeah, so we could actually use those tests. So it wasn't just we weren't just using testability features, we were actually like complementing it with real end-to-end testing.
Okay. What about highs and bugs? Instrumentation changes outcome and prevents reproduction. So what do you do when your actual instrumentation and your test hooks cause something to change?
I guess we didn't see that a whole amount. These, like any of these testability like hooks or changes were like completely reproducible in a development environment. So it was very easy to run our app locally in debug mode and actually use one of these like testability features and see exactly what was happening. And just running it in debug, you could actually see the values of everything. So I guess being able to do that, we could actually like iron out whether there were any issues in that. But the benefits far outweighed any like issues that we ever had with that. I've never heard of Heisenbugs, but I'll look that one up.
Was it difficult to convince people to undertake this effort?
Yeah, it was. Like particularly developers, because as I said, like with the question we had before, like it is a fair bit of effort, but it is about, I guess, changing your focus. It was hard to convince people, but as soon as we actually made some gains and like just taking like a single bug that you have in production and then like saying, oh, how can we test this like smartly, introducing a testability feature for it and actually doing that by doing like small examples and proving and showing how they can be effective, you soon get buy-in. And then basically, as I said before, like as soon as you have consistent builds passing, everyone thinks it's the best thing in the world because they're no longer like questioning the quality.
I'm going to throw in my own follow-up question, which is how do you measure flakiness and sort of follow that along? Because you're talking about like, you know, showing proof of concept and then iterating on that. How do you actually measure flakiness?
I guess the only way you can really measure it is by every fail build that you have, looking at it and then just asking whether it's a legitimate fail. And so firstly, like I guess reducing how many failed builds you have, and then if you are having builds that have failed, just look at them and say, hey, is this a legitimate bug? And how easily you can determine, how quickly you can determine that, hey, this is a legitimate bug that we need to fix. And then as soon as you start realizing that every build that fails is a legitimate bug, then I guess that's when you've got confidence that you have eliminated flakiness.
One last question. What helps you to inculcate? You guys are teaching me new words. Thank you. A culture of testable design within the developer community. What do you do when they want to cut corners to release urgent features?
Again, a really good question. I think it sort of goes back to what I said, that it is really like a long-term view, and it's just really like showing, like demonstrating the ability of like, well, the effectiveness of doing this, and then in small amounts, and then sort of gaining momentum over time. And like ultimately, like every developer I've worked with has actually sort of been involved in this. Ultimately, they love it because it gives them really good confidence to make changes, which every developer wants. It gives them really good confidence to do a release, and it reduces how many calls they get after hours because something's crashed. Yeah, everyone I've been involved with has actually like loved this process, but it's just a matter of like changing that culture over time. And really, the only way to like deliver like fast software sustainably is to have like very reliable, non-flaky tests.
Thank you, Alister.
Thank you.